Hello, Mastery Algebra 1, I'm Mr. White. This is the first of two videos for Section 6.3, Solving Systems by Elimination. This is the third way to solve a system. Like graphing, we had substitution done by Mr. Fuller, and now we are looking at elimination. So problem number 1, we want to find out what is the solution of a system using elimination. And the first thing we want to ask ourselves is, we have to eliminate one of the variables. We have to either eliminate x or we have to eliminate y. And you can eliminate either variable, but since the y has coefficients of 5 and negative 5 and they are opposites, let's just add those together and we can eliminate y. So if we draw our line here, we're going to add straight down. So 2x plus 6x gives us 8x. By adding the 5y and the negative 5y, we're going to get 0. So we get 8x is equal to 17 minus 9, which is 8. So when we divide by 8, we get x equal to 1. Okay. Now we're going to take one of our two equations. Let's say we just take the first one. Now in order to find the y, we're going to take this x, which is 1, and we're going to substitute it in for x into, say, the first equation. You could use the second equation, but I'm just going to use the first. When we plug in 1 for our x, we're going to get 2 times 1 plus 5y equals 17. We need to solve for the 5y, so we're going to subtract this 2 over. Draw a line, we're going to get 5y is equal to now 15. So when we divide by 5, we get y equals 3. So our system that we have is 1 for x, comma, 3. We need to check. So let's plug both back in and see 1 if we get 17, 2 if we get negative 9. So our checks, make sure you do checks for both equations. So we're going to say this one's going to be the 2x plus the 5y equals 17. And then we'll do the other one, 6x minus 5y equals negative 9. So write the original equations. We'll input 1, so 2 times 1 plus 5 times 3 should equal 17. 2 plus 15 should equal 17, and we get 17 equal to 17. So that checks out. Now we do the same thing over here. 6 times 1 minus 5 times 3 should equal negative 9. 6 minus 15 should equal negative 9. 6 minus 15 is negative 9. So negative 9 equals negative 9. So our solution is 1, 3. Number 1 on the got it. We have 5x minus 6y equals negative 32. We have 3x plus 6y equals 48. We need to look at what can we solve for. Well, if we notice these y's again, these y's are opposites. So if we just simply add straight down, we're going to get, again, 8x is now equal to 48 minus 32, which is 16. Okay, we have one variable, so let's divide by 8. And we're going to get x is equal to 2. Let's take our information. Let's input this. Let's use the, so we're going to plug in 2 for x. So we have 3 times 2 plus 6y should be equal to 48. 3 times 2 is 6. Plus 6y equals 48. So when we subtract 6, we're going to get 6y is equal to 42. Now divide by 6, y is equal to 7. Okay. So right now we have a point that is x equals 2, comma, y equals 7. Okay. Let's again do our checks. So our checks over here, we'll go ahead and write checks. So we have 5x minus 6y equals negative 32. And we have 3x plus 6y should be equal to 48. 5 times 2 minus 6 times 7 should be equal there. 10 minus 42. 10 minus 42 is negative 32. which is equal to negative 32. So that checks out. For the next one, 3 times 2 plus 6 times 7 should be equal to 48. 3 times 2 is 6 plus 42 should be equal to 48. 6 plus 42 is 48. Woohoo! So, we have a solution that was 2, 7. Okay. Problem number 2. This is multiplying one equation now. So for the beginning two, we didn't have to multiply anything. We already had opposites. We have a theater club that sells a total of 101 tickets to its first play. A student ticket costs $1 and an adult ticket costs $2.50. Total ticket sales were 164, so how many student tickets were sold? Okay, so the first thing we have to think about is, what's the question that we're being asked, which is, well, how many student tickets were sold? And there's also adult tickets. So there's our variables right there. We're going to say, hey, you could say S. I just happen to say X. So let's X equal the number of student tickets. Okay, we also have adult tickets. So let's call that Y. We're going to let Y be the number of adult tickets. Okay. So a quantity amount, meaning there's always one thing, we have 101 tickets sold between student and adult tickets. So one equation, because we need to write two equations, one equation that we can write is the number of student tickets plus the number of adult tickets should be equal to 101. So X plus Y should be equal to 101. We also have a total amount. So we know that the total amount sold was 164. Okay, and that was made up of X student tickets and Y adult tickets. But it's a dollar amount, so we know that each student ticket was $1, so we're going to attach a 1. Okay, and each adult ticket was $2.50, so we're going to multiply 2.5 to the Y. So 2.50 to the Y. So we have now two equations. Okay, again, our goal is to eliminate one of the variables. Well, if we notice, here we have a 1y and a 250, but we have a 1x and a 1x. So we just need to get opposites. So if we multiply, let's say to this first equation here, if we multiply negative 1 to this whole equation, we're going to get negative 1x minus y equals negative 101. By doing that, these x's will cancel. So if we take 250 minus $1, we're going to get $1.50y, which is equal to 164 minus 101 is going to give us 63. Okay, now to solve for y, we're going to divide by 150, divide by 1.50, and we end up getting y is equal to 42. Okay. Now we have to input, let's just take our first equation because we know y tickets plus x tickets should equal 101. So if we go x plus the 42, that should give us 101. Subtract 42, subtract 42, x should be equal to 59. So our point we got was 59 for x and 42 for y. Or if we write a sentence, what can we say? The theater club sold 59 student tickets and 42 adult tickets. All right, go ahead and hit pause. Try number 3. This is, again, now you have to multiply one equation and then solve the system. Be sure to do your checks. Go. All right, welcome back. What you should have seen, I got rid of the y by multiplying by 3. So that made one 15y and one negative 15y. So I ended up getting x equals 2. Substituted into the bottom equation. Okay, got y equals negative 2. Okay, and the checks work out. All right, problem number 4. Your talent show will feature 12 solo acts, 2 ensemble acts. The show will last 90 minutes. The 6 solo performers judged best will give a repeat performance at a second 60-minute show, which also features the 2 ensemble acts. Each solo act lasts X minutes, and each ensemble act lasts Y minutes. Okay. What do we need to find? We need to find how long a solo act lasts and an ensemble act. So we can say let X be the number of minutes for solo acts and Y be the minutes for an ensemble. Our 2 equations. We have one show that lasted 90 minutes. So if we know one lasted 90 minutes that was made up of X and Y, well, how long was an X? How many? So there were 12 solo acts plus the 2 ensemble. Okay, that was made up of 90 minutes. Okay, then we actually had another one which was 6 solo performers. So we go 6x plus the 2 ensembles, and that was for a total of 60 minutes. Go ahead, hit pause. Again, solve for X and Y, and be sure to write your sentence because it is a word problem. See you back here in a few minutes. Go. Alright, welcome back. You should have seen you had 5 solo acts and 15 ensembles. Make sure you write a sentence. Alright. Be sure to do page 381, 1, 2, 7, 8, 9, 13, and 35. Okay, solving a system by elimination. So again, this is the first part of 6.3. Once you finish this, go on to 6.3b, and I'll see you again. Always remember, do your best, forget the rest. Bye for now.